Hello viewers, I welcome you to the lecture series on computer networks. Today we will understand and learn about application layer protocols and services. We will try to look into the basic concepts related to the application layer like Internet, World Wide Web, HTTP, DNS and URL, protocols related to the application layer and various services provided by application layer. Now before we start our main topic, let's get familiar with the Internet and World Wide Web. As we all know that the Internet has become so ubiquitous, it's hard to imagine life without it. Internet in today's life is an integral part of our daily routine. Moreover, access to the Internet is now becoming a requirement these days. We experience the Internet through the World Wide Web in many ways, like while emailing and chatting with friends, playing online games, doing online shopping for deals on websites and streaming videos. Basically, all these applications that we use provide the human interface to the underlying network. They enable us to access the data across network more efficiently and with relative ease. Typically, we use these applications without even knowing how they actually work. Now being a formal internet user, we really don't have to care about all these things at all. Our task is to access the information from internet. Now how this information is accessed actually. However, for network professionals, it is important to know how an application is able to format, transmit and interrupt messages that are sent and received across the network. What is application layer? Here is a diagram for the OSI reference model and TCP/IP model. Virtually all networks in use today are based in some fashion on the Open System Interconnection Standard. OSI was developed in 1984 by the International Organization for Standardization, that is ISO, a global federation of national standards organizations representing approximately 130 countries. The core of this standard is the OSI reference model, a set of 7 layers that define the different stages that data must go through to travel from one device to another over a network. As we all know that the OSI reference model is a set of 7 layers which are as follows: physical layer, data link layer, network layer, transport layer, session layer, presentation layer and application layer. And the TCP/IP reference model consists of 4 layers as follows. First one, network access layer, also known as host to network. Second, internet layer, transport layer and last, application layer. As we can see, the topmost layer in both reference model is common, that is application layer. And this is the core part of our topic. Let's understand now the definition of application layer first. What is it actually? Application layer is a logical layer and the highest most layer in both OSI and TCP/IP layered model. All the layers in the OSI reference model are logical except first layer, that is physical layer. The application layer exists in both layered models, so it got a very important significance, which is interacting with user and user applications. This layer is for those specific applications which are involved in communication system. In other words, the OSI reference model defines the application layer as being the user interface. So it is clear from the definition that application layer deals with interacting user and variety of user applications. Next issue which comes to our mind is why we need this application layer. What is the major purpose of this layer? So let's understand now what the purpose of application layer is exactly. When we talk about internet, there are 2 things we need to concern about: how do we connect and how we can access or share the information. Like we earlier said, if you are a formal user, then you will not be interested in understanding how do we connect to the internet, but our main purpose is how to get, share and access information from internet. So accessing the information from internet is more important than connecting to the internet. If you are connected to the internet by any means and still not able to access it, then there will be no use of this internet. That is where application layer comes into play. The application layer enables the user, whether it's human or software, to access the network. It provides user interfaces and support for services such as electronic mail, remote file access and transfer, etc. So the major role of application layer is that the application layer is responsible for providing services to the user. So far we understand what is application layer and what is its purpose. Next part of our discussion is application layer protocols. Now we will discuss the application layer protocols. What is a protocol? In information technology, a protocol is a specific set of rules, agreements used between two or more endpoints. When we use protocol in your daily life, example, say you go to the library, you ask to a specific book, the librarian goes, do you have any ID? You give him your ID. If it's okay, then he gives you required book. This is a protocol, ID. This is the protocol for issuing books. You both understand each other about what needs to be done. Same with computers. Computers have protocols for the web, that is HTTP, transferring files, that is FTP, then the internet, that is IP Internet Protocol. We often use the terms application, program and software. Don't confuse application with program or softwares. There is an ambiguity in understanding application layer and its protocol. We cannot put every user application into application layer, but only those applications which interact with the communication system. Like in the internet layer, we use IP addresses. Here we use emails and domain names as addresses. Let's take an example of any often used application like designing software or text editor. We cannot consider them as application layer programs. On the other hand, when we use a web browser which is actually using HTTP Hypertext Transfer Protocol to interact with the network, we can say HTTP is application layer protocol we take into consideration when we study layered models. So it is not important what software we use. It's the protocol which is considered at application layer used by that software. Next we have the types of protocols in application layer. The application layer supports various protocols as given below, like remote login category, telnet, file transfer category, FTP, electronic mail category, SMTP, IMAP, POP, support services category, DNS. Other protocol examples are HTTP, that is Hypertext Transfer Protocol, DHCP, Dynamic Host Configuration Protocol, ARP, Address Resolution Protocol, etc. As we mentioned above, there are a variety of protocols used at application layer, but at this moment we will discuss about HTTP, that is Hypertext Transfer Protocol, and DNS, that is Domain Name System. Let's start with the HTTP first, as we are discussing or using this name very frequently. HTTP is a set of standards which is mainly used to access data on the World Wide Web, or that allow users of the World Wide Web to exchange information found on web pages. Let's understand it this way. Whenever we want to access any web page, we always enter HTTP // in front of web address, which tells the browser to communicate over HTTP. For example, the full URL Uniform Resource Locator is written as http / www.google.com. It is not important that you need to write the full URL every time you access the internet. In the address bar, you can simply write, say, Google, then press Ctrl plus enter and you are on www.google.com, as simple as that. Moreover, today's modern browsers no longer require even HTTP in front of the URL, since it is the default method of communication. But it is still used in browsers because of the need to access other protocols such as FTP through the browser. Below are a few of the major facts on HTTP. The term HTTP was coined by Ted Nelson. HTTP 0.9 was the first version of the HTTP and was introduced in 1991. HTTP 1.0 is specified in RFC, that is Request for Comments, 1945 and introduced in 1996. HTTP 1.1 is specified in RFC 2616 and officially released in January 1997. Beside these facts, we must remember that HTTP transfer files and uses the services of TCP on well-known port 80. As we are talking about HTTP now, these days we also use the term HTTPS. I will not be going into detail, but let's know what is Hypertext Transfer Protocol over Secure, abbreviated as HTTPS. Is a secure method of accessing or sending information across a web page. All data sent over HTTPS is encrypted before it is sent. This prevents anyone from understanding that information if intercepted. Because data is encrypted over HTTPS, it is slower than HTTP, which is why HTTPS is only used when requiring login information or with pages that contain sensitive information. For example, while doing online transaction on a bank web page, using debit or credit card, while doing online shopping, etc. This is all about HTTP and HTTPS. Next protocol which falls under the support service category is DNS, that is Domain Name System. Let's get familiar with the domain name first. Domain is basically the part of a network address that identifies it as belonging to a particular domain. For example, the domain name Microsoft.com represent about a dozen IP addresses. Domain names are used in URLs to identify particular web pages. For example, in the URL http www.microsoft.com, the domain name is Microsoft.com. Every domain name has a suffix that indicates which top level domain, that is TLD, it belongs to. There are only a limited number of such domains. For example, GOV, known as government agencies, EDU belongs to educational institutions, ORG, organizations which are non-profitable, MIL belongs to military, COM for the commercial business, NET, network organizations. So as we now are familiar with the domain name, let's get introduced with the DNS, that is abbreviated as Domain Name System. If you have ever used the internet, then you have used the domain name system or DNS even without realizing it. DNS is a protocol within the set of standards for how computers exchange data on the internet. We humans can easily remember names, and domain names are alphabets like yahoo.com, google.com, wikipedia.org, etc. But on the other hand, computers are good with numbers. Computer can easily understand numbers 0, 1. So the basic job of DNS is to turn a user-friendly domain name like google.com into an IP address like 70.42.251.42 that computers use to identify each other on the network. It's just like your computer's GPS for the internet. Basically, if we are asked to find a computer on the network, it can be done in two ways. We are familiar with the physical address, that is MAC address, and logical address, that is IP address. So these are the two basic entities used for identification of any computer on the network. If we are given with both physical and logical addresses, it is easy to locate a particular computer on network. But problem arise if we either given with one address, physical address or logical address at a time. In order to overcome this problem and in order to identify a computer on the network, we have two protocols. First one, ARP, Address Resolution Protocol. Second, RARP, that is Reverse Address Resolution Protocol. Here is a diagram which is show the logical data flow for the Address Resolution Protocol and Reverse Address Resolution Protocol. As we all know that each network interface cards, NICs, have a hardware address or MAC address associated with them. Applications understand TCP/IP addressing, but network hardware devices such as network interface cards do not. For example, when two Ethernet cards are communicating, they have no knowledge of the IP address being used. Instead, they use the MAC addresses assigned to each card to address data frames. So, the Address Resolution Protocol was designed to provide a mapping from logical TCP/IP addresses to the physical MAC addresses. In other words, we can say that it defines a method that is used to ask and answer the question which IP address corresponds to a given MAC address. On the other hand, the job of RARP is reverse of ARP. That's why it is called Reverse Address Resolution Protocol. RARP is used when the MAC address is known but the IP address has not been identified. In other words, we can say that it defines a method that is used to ask and answer the question which MAC address corresponds to a given IP address. So, we can summarize it in one line that ARP translates IP addresses into MAC addresses. The Reverse Address Resolution Protocol or RARP is used to find a TCP/IP address from a MAC address. Next thing we need to understand is WWW, that is World Wide Web. Now we often use terms internet and WWW every day. Here we need to realize that internet is a hardware thing and WWW is a software thing. Internet is a collection of nodes. We can actually see the nodes connected with each other. On the other hand, WWW, that is World Wide Web, is a software or system which is used to access the information from internet. We will start with the definition of World Wide Web first. World Wide Web, abbreviated as WWW or W3, is a system of interlinked hypertext documents which can be accessed via the internet. The web is not the only system out there, but it's the most popular and widely used. There are several applications that make it easy to access the World Wide Web. There are many web browsers around which can be used to access internet. The most popular web browsers are Mozilla Firefox, Google Chrome and Internet Explorer. With the help of these web browsers, we can view web pages that may contain information or data like text, images, videos and other multimedia. We can also navigate between them from one page to another via hyperlinks. This is little detail about the World Wide Web. So till this topic we learned internet, application layer, the purpose of application layer, the protocols associated with the application layer and the full URL, that is Uniform Resource Locator. Now we are left with application layer services. So far we have understood that the application layer provides variety of support and services. As we have mentioned above, there is a wide range of application services which are used at application layer, but we don't need to discuss all of them. Very specific services provided by the application layer are as follows. The first one, file transfer, access and management. This application allows a user to access files in a remote host, that is to make changes or read data, to retrieve files from a remote computer for use in the local computers. Second one is Mail services. This application provides the basis for email forwarding and storage. The third one, directory services. This application provides distributed database sources and access for global information about various objects and services. To conclude, in this lecture, we learn about the application layer protocols and services. We will try to look into the basic concepts related to the application layer like Internet, World Wide Web, HTTP, DNS and URL, protocols related to the application layer and various services provided by application layer. So thanks for watching the program.